It's Saturday night, and you're looking forward to a fun and exciting evening with your friends. What wild and crazy events do you have planned? Maybe pizza? A movie? Some root beer floats? Nope, nope, and nope. Well then, what is this fun and exciting evening? You and your friends are about to have a chemistry party. So grab your test tubes, goggles, and lab coats and prepare to have a wild and crazy chemistry-filled night. You'll start the evening by gathering some ice cubes and placing them on the kitchen table. Sure, watching ice melt doesn't sound particularly exciting, but there's actually a lot going on with the molecules inside that ice cube. Before we talk about the molecules, let's go over some vocabulary. Melting, or fusion, is when a solid turns into a liquid. Freezing, or solidification, is when a liquid turns into a solid. I'm sure you've heard the words melting and freezing before, but fusion and solidification may be new to you. Okay, back to your ice cube. Heat energy from the table causes the molecules in the ice cube to start moving faster. They also get farther and farther apart. In order to change a solid to a liquid, there's a certain amount of energy required. This is called the heat of fusion. Remember, fusion means melting, so you can see where it gets its name. Anyways, the heat of fusion is the amount of energy required to change a substance from a solid to a liquid at its melting point. It's worth noting, it takes energy for something to melt, but energy is given off when something freezes. Also worth noting, there's a heat of solidification, which is the energy released when a liquid turns into a solid at its freezing point. Remember, solidification means turning a liquid into a solid, so you can see how heat of solidification gets its name. But for now, the focus of your chemistry party is the heat of fusion and that melting ice cube. So back to that. The heat of fusion can be measured in joules per gram, or J per G, or calories per gram, or cal per G. To keep things simple, we'll just use calories per gram in this lesson. Both joules and calories are measurements of energy. You may be familiar with calories with a capital C, which is also known as a kilocalorie, or the calorie you see on a food label. Just so you can relate to what a calorie is, there are 1,000 calories in one food calorie, or kilocalorie. So your ice cube melted, and now you have a puddle of water on your kitchen table. You might be thinking your chemistry party is coming to an end, but don't worry. Things are about to get even more exciting. There's a formula you can use that involves the heat of fusion, and here it is. The heat of fusion equals heat energy divided by mass, where the heat of fusion is H subscript F, mass is M, and heat energy is Q. And since it's a chemistry party, I think we should try out this formula. Let's try to figure out how much heat energy was required to turn that ice cube into a liquid puddle at its melting point. In other words, we'll use the formula to solve for Q. Step 1. We need to determine the mass of the ice cube in grams. Don't worry if you don't have a scale available, I'll help you out. Your ice cube's mass is 4 grams, so M equals 4 grams. Step 2. Figure out the heat of fusion for water. There are tables available on the internet and in some chemistry textbooks. Each substance has its own heat of fusion, and water's heat of fusion is 79.7 calories per gram. Step 3. Plug these into the equation and solve for Q. Multiply by 4 grams on both sides so you can get Q by itself. Your answer is 318.8 calories. So it takes 318.8 calories to turn a 4-gram ice cube into a liquid, which is less than 1 food calorie. Remember, there are 1,000 calories with a little c and one of the calories with a big C that we're familiar with from food labels. Just when you thought your ice melting party couldn't get any more exciting, let's boil some water. But let's get a couple of new vocabulary words out of the way first. Boiling, or vaporization, is when a liquid is changed into a gas, and condensation is when a gas is changed into a liquid. Okay, so let's put some water in a pot and watch it boil. As the water gets hotter, the molecules start bouncing around like crazy and keep getting farther and farther apart. The heat of vaporization is the amount of energy required to turn a liquid into a gas at its boiling point. Just like with melting, it takes energy to change a liquid into a gas. but energy is lost when a gas is changed into a liquid. There's also a heat of condensation, which means the amount of energy that is released when a gas turns into a liquid at its condensation point. But our focus here is the heat of vaporization. And you guessed it, there's another formula for you, but don't worry, it's very similar to the first one. The heat of vaporization equals heat energy divided by mass, where the heat of vaporization is represented by H subscript V, mass is still M, and heat energy is still Q. Just to make sure you understand, let's do a problem with this formula. Let's try to figure out how much heat energy is required to boil water at its boiling point. Step 1. Well, you need to figure out the mass of water. Wait! Don't pour it out on the scale. You can find its mass by putting a pot on the scale, zeroing it out, and then adding the water. Okay. It looks like it's 4 grams, so M equals 4 grams. Step 2. We'll need to find out the heat of vaporization for water, which can be found on the internet or on a table in a textbook. It's 539 calories per gram, so the heat of vaporization, or H subscript V, equals 539 calories per gram. Step 3. Now we'll plug those numbers into the formula and solve for Q, like before. If you multiply 4 on both sides, you get 2,156 calories, which is about 2 food calories if you're curious. So you probably noticed it takes a lot more energy to boil water than it does to melt it. It's getting late, so it's time to wind down your chemistry party. But I bet on Monday your party will be the talk of the town. Let's review some important terminology so you can tell everyone how awesome your night was. When a solid becomes a liquid, it's called melting or fusion. Melting requires energy, whereas freezing loses energy. The heat of fusion is the amount of energy required to change a solid into a liquid at its melting point. When a liquid becomes a solid, freezing or solidification has occurred. When a liquid turns into a gas, it's called boiling or vaporization. The heat of vaporization is the energy required to change a liquid into a gas at its boiling point. Boiling requires energy, whereas condensation loses energy. Both the heat of fusion and the heat of vaporization are part of a formula. Now that you're armed with your heat of fusion and your heat of vaporization information, you're about to be one hot chemist, but not too hot. You don't want to vaporize. Get it?